Picture this: centuries ago, gazing at the stars was just a way to navigate the seas or mark the seasons. Then everything changed when we pointed our first telescopes upward. That simple act cracked open a cosmic door we never knew existed. Think about it: the very technology in your smartphone, the GPS guiding your road trips, even the weather forecasts you rely on, all these sprang from our hunger to understand the great beyond. Now fast forward to today, we're standing at another extraordinary turning point. Hidden among distant galaxies and strange new worlds are 20 jaw-dropping space discoveries that could reshape our entire existence. We're not just talking about minor upgrades to your daily life. These revelations could rewrite human history, from turning planets into new homes to uncovering alien life forms that challenge everything we know. Some might power our cities with star energy. Others could reveal we're not alone in this vast universe. Buckle up, because we're about to journey through cosmic breakthroughs so powerful, they might just redefine what it means to be human. And the best part, these aren't science fiction dreams, they're real discoveries happening right now in labs and observatories across the globe, ready to have your mind blown by what's waiting out there in the dark. Let's dive in. Now here's something that changes everything we thought we knew about our rusty red neighbor. Not long ago, scientists made a bombshell announcement: they found liquid water hiding beneath the surface of Mars. This wasn't just some scientific footnote. Imagine discovering an underground lake on a planet we've been calling a desert world for centuries. The European Space Agency's Mars Express spacecraft first picked up radar signals showing what looked like a 20-kilometer-wide saltwater lake nearly 1.5 kilometers below the southern ice cap. Then NASA's Mars instrument confirmed it wasn't just a fluke. They found even more pockets of briny water scattered beneath the surface. This changes the game completely when it comes to human survival on Mars. Water means potential drinking sources after treatment. It means oxygen can be extracted through electrolysis. Most exciting of all, it means rocket fuel can be produced right there on Mars by splitting water into hydrogen and oxygen. Suddenly, the idea of a self-sustaining Mars colony doesn't seem so far-fetched. Scientists are studying how these underground reservoirs formed and whether they've remained liquid due to heat from the planet's interior or dissolved salts lowering the freezing point. The implications for astrobiology are even more staggering. Where there's liquid water, there could be life, the same way extremophile organisms thrive in Earth's most hostile environments. Similar microbes might exist in Mars' underground lakes. The upcoming ExoMars rover mission plans to drill 2 meters down to search for signs of past or present life. If we find even simple microbial life with a completely different origin story than Earth's, it would prove life isn't some rare cosmic accident. What's truly revolutionary is how this discovery reshapes interplanetary travel. Future astronauts wouldn't need to haul all their water from Earth, they could extract it locally. NASA Perseverance rover has already demonstrated converting Martian carbon dioxide into oxygen. Combine that with water ice mining and you've got the basic survival elements covered. Private companies are already developing water extraction technologies, with SpaceX's Starship intended to eventually carry hundreds of settlers to establish a permanent presence near these vital water sources. Ongoing research keeps revealing more surprises. Recent scans suggest some underground water may exist much closer to the surface in certain regions. The SHARAD instrument on NASA's Mars Reconnaissance Orbiter has detected layered ice deposits that could be tapped with relatively simple equipment. As we prepare to send humans to Mars within the next 2 decades, these watery discoveries are shifting from scientific curiosities to essential survival resources. That shimmering blue dot we call home might soon have a sister world where humanity takes its next great leap. Speaking of leaps, this discovery connects perfectly to another cosmic revelation that's rewriting the rules of planetary science. Scientists have found worlds orbiting distant stars that look suspiciously like our own planets, where the conditions might be just right for life as we know it. But these aren't the hostile environments we once imagined. Now let's turn our gaze beyond our solar system to something equally mind-blowing: planets circling other stars that might just be twins of Earth. For centuries, we wondered if worlds like ours existed elsewhere. Today, thanks to telescopes like Kepler and TESS, we know they're out there by the thousands. The real game changers are those rare exoplanets sitting in the Goldilocks zone, not too hot, not too cold, but just right for liquid water to exist on their surfaces. Take Kepler 186f, for example. This Earth-sized planet orbits a red dwarf star about 500 light-years away, bathed in gentle starlight that could keep temperatures in the perfect range for liquid water. Then there's Proxima Centauri b, our closest exoplanet neighbor at just over 4 light-years away. It's locked in a tight orbit around a faint red star, but if it has a thick enough atmosphere, heat could spread evenly across its surface, creating pockets where life might thrive. What makes these discoveries revolutionary isn't just their Earth-like size or position. It's the possibility that they could host atmospheres with telltale signs of life, biosignatures like oxygen, methane, or even industrial pollutants. Right now, missions like the James Webb Space Telescope are analyzing the light filtering through exoplanet atmospheres, hunting for these chemical fingerprints. The European Space Agency's upcoming Pluto mission will scan nearby stars for rocky worlds, while NASA's Habitable Worlds Observatory, set for the 2030s, will directly image exoplanets to study their weather patterns and surface features. But here's where it gets even wilder. If we confirm habitability, these worlds could become interstellar backup plans for humanity. Proxima Centauri b is close enough that projects like Breakthrough Starshot, which aims to send tiny probes there at a fifth of light speed, could give us our first close-up data within decades. Settling these worlds would be a colossal challenge. Red dwarf stars often blast planets with deadly flares, and tidal locking could leave one side in eternal darkness. Yet, if we find an exoplanet with a stable climate and protective magnetic field, generation ships or advanced propulsion might one day carry colonists. The search for extraterrestrial life ties directly into these discoveries. If simple organisms exist on a habitable zone exoplanet, it would mean life is likely common in the universe. If we find complex ecosystems, it could redefine our place in the cosmos. And if we detect artificial signals or megastructures, that's a conversation starter for the ages. As our telescopes grow sharper, each new exoplanet discovery chips away at Earth's uniqueness. Soon, we might point to a dot of light in the sky and say, that's not just a star, that's someone's sun. Speaking of cosmic mysteries, there's another celestial body in our own solar system that's hiding surprising secrets beneath its icy shell. Now, let's dive closer to home, well, closer in cosmic terms, to a tiny moon of Saturn that's punching far above its weight in the search for life. Enceladus, a frozen world barely 300 miles wide, might seem like an unlikely candidate for harboring life at first glance. But beneath its icy crust lies a secret that has scientists buzzing: a vast, salty ocean constantly erupting into space through towering geysers. And where there's water, heat, and organic molecules, the ingredients for life might just be simmering. The Cassini mission, which orbited Saturn for over a decade, gave us our first jaw-dropping glimpse of these plumes. As the spacecraft swooped through the icy spray, its instruments detected something extraordinary: complex organic compounds like methane, propane, and even hints of amino acids, the building blocks of protein. These aren't just random chemicals, they're the same kind of molecules that kick-started life on Earth. What makes Enceladus special is how these ingredients are being actively mixed. Hydrothermal vents on its ocean floor, much like those in Earth's deepest seas, could be churning out energy and nutrients, creating pockets where microbial life might thrive. But why does this matter beyond textbooks? For starters, Enceladus offers a pristine lab for studying how life might emerge in icy ocean worlds, a scenario that could be common across the universe. If microbes are swimming in its dark waters, it would suggest that life doesn't need sunlight or a cozy Goldilocks zone to get started, just a heat source, water, and the right chemistry. That flips the script on where we should look for aliens. Suddenly, frozen moons like Jupiter's Europa or even distant Pluto-like objects become prime real estate for exploration. The practical implications are just as thrilling. Enceladus plumes vent material directly into space, meaning a future mission could sample its ocean without drilling through miles of ice. Imagine a probe flying through these geysers, analyzing droplets for signs of living cells or their metabolic byproducts. NASA are already sketching concepts like the Enceladus Orbiter, which would orbit the moon before landing near a plume to study its chemistry up close. A detection of life here wouldn't just rewrite biology, it would give us a roadmap for where to hunt next, from Saturn's other moons to the icy dwarfs of the Kuiper Belt. And let's not forget the bigger philosophical question. If life can spark independently in our solar system twice, how many other Enceladus's are out there? Every icy moon we find with a subsurface ocean becomes a potential oasis. That's why missions like Europa Clipper and Japan's proposed Martian moon e-exploration aren't just science projects, they're humanity's way of testing whether we're alone in the dark. So while Enceladus might look like a frozen pebble from afar, it's proof that sometimes the most unassuming places hold the keys to the universe's greatest mysteries. And speaking of cosmic oddities, our next discovery hurtles in from beyond the stars, an object so strange it sparked debates about alien technology. Now, let's shift our gaze from the hidden oceans of Enceladus to something far more fleeting, a cosmic visitor that raced through our solar system, leaving scientists scrambling to unravel its secrets. In October 2017, astronomers spotted an object unlike anything we'd seen before. It wasn't from our solar system. It wasn't even sticking around. This was Oumuamua, the first confirmed interstellar visitor, and its bizarre behavior sparked debates that still echo through the scientific community. At first glance, Oumuamua seemed ordinary, a reddish, rocky body hurtling through space. But the closer researchers looked, the stranger it became. Its shape was all wrong. Most asteroids and comets are lumpy or spherical, but Oumuamua was elongated, stretching perhaps 600 feet in length, while being only about 60 feet wide, like a cosmic cigar tumbling through the void. Then there was its movement. Instead of slowing down as expected, it sped up slightly as it left the solar system, as if pushed by an unseen force. Comets often accelerate due to outgassing ice vaporizing into jets, but Oumuamua showed no visible coma or tail. So what was propelling it? This is where the theories diverge. Some scientists propose natural explanations. Maybe Oumuamua was a shard of a shattered planet, ejected during a violent cosmic collision eons ago. Its odd acceleration could have been caused by hidden outgassing, with sun-warmed hydrogen ice releasing gas too faint for our telescopes to detect. Others suggest it was a rare hydrogen iceberg, a theoretical object made entirely of frozen hydrogen that would leave no trace as it vaporized. But then there's the more provocative idea: could Oumuamua have been artificial? Harvard astronomer Avi Loeb famously suggested it might be a light sail, a thin, reflective structure propelled by starlight, possibly of alien origin. After all, its flat shape and unexplained acceleration fit the profile of a technology humans are already developing for interstellar probes. While most scientists consider this unlikely, the mere possibility forces us to confront a thrilling question. If an alien craft ever did pass through our solar system, would we even recognize it? Beyond the intrigue, Oumuamua's visit taught us two groundbreaking lessons. First, interstellar objects are likely far more common than we thought. Before 2017, their existence was purely theoretical. Now we know they're out there, and new telescopes like the Vera-C Rubin Observatory will soon spot dozens more, helping us map the diversity of materials floating between stars. Second, studying these visitors could reveal the composition of distant star systems without ever leaving our cosmic neighborhood. Imagine analyzing chunks of an exoplanet's crust or fragments from an alien asteroid belt, all delivered to our doorstep by the galaxy's natural delivery system. NASA already planning for the next Oumuamua. Projects like the Comet Interceptor mission aim to park a spacecraft in orbit, ready to chase down the next interstellar passerby. With better data, we might solve the riddle of Oumuamua's acceleration, or, who knows, stumble onto something even more extraordinary. Because if there's one thing this cosmic oddity proved, it's that the universe loves to surprise us. And speaking of surprises, our next discovery isn't just mysterious, it's downright explosive. Fast radio bursts are some of the most energetic signals in the cosmos, and we're only beginning to understand what's causing them. Now, let's turn our attention to one of the most explosive puzzles in the cosmos: fast radio bursts. Imagine a signal so powerful it releases more energy in a millisecond than the sun does in 80 years, yet vanishes before we can fully grasp its origin. These are FRBs, and they've been baffling astronomers since the first one was detected in 2007. What makes FRBs so intriguing is their sheer intensity and unpredictability. Some burst once and never repeat, while others, like FRB 121102, flash at regular intervals like a cosmic heartbeat. The leading theory points to neutron stars, especially magnetars, stellar corpses with magnetic fields 1 trillion times stronger than Earth. When these magnetars experience starquakes or magnetic eruptions, they could unleash the colossal bursts we detect. But there are outliers. Some FRBs pulse with patterns too precise to easily explain, fueling wilder speculation. Could they be artificial? The idea isn't entirely far-fetched. If an advanced civilization wanted to broadcast their presence or even power interstellar probes, channeling energy into a focused radio beam might be their method of choice. The real game changer, though, isn't just solving the mystery, it's harnessing FRB's potential. These bursts traverse billions of light years, passing through ionized gas and magnetic fields that subtly alter their signals. By studying these distortions, scientists could map the universe's hidden matter, like a cosmic X-ray revealing the skeleton of galaxies. Even more revolutionary, decoding FRBs might unlock new physics. Their extreme energy could teach us about plasma behavior or even space-time itself, insights that might one day lead to breakthroughs in wireless energy transmission or quantum communication. Projects like the CHIME telescope in Canada are now spotting FRBs almost daily, while upcoming missions aim to pinpoint their exact sources. Each detection brings us closer to answers, whether they're natural cosmic fireworks or something far more extraordinary. Because if there's one lesson from FRBs, it's that the universe is far stranger and far more inventive than we ever imagined. And speaking of cosmic ingenuity, our next discovery isn't just about observing the universe, it's about decoding its invisible blueprint. Dark matter makes up 85% of the cosmos, yet we've never seen it directly until now. Shifting our gaze to the universe's hidden scaffolding, let's unravel the enigma of dark matter. Think of it as the cosmic glue holding galaxies together, yet it's utterly invisible: no light, no reflection, just gravitational whispers. For decades, scientists have pieced together its existence indirectly, observing how its gravity bends starlight and sculpts the cosmos. But now, missions like Euclid are poised to illuminate this shadowy realm like never before. Euclid, launched by the European Space Agency, isn't just another telescope. It's a cosmic cartographer designed to map the distribution of dark matter across 1/3 of the sky over 6 years. How? By exploiting gravitational lensing, an effect where dark matter's gravity warps the light from distant galaxies, distorting their shapes like a funhouse mirror. By analyzing these distortions, Euclid will trace dark matter's invisible threads, revealing how they weave the universe's large-scale structure. But why does this matter? Dark matter isn't just a cosmic curiosity, it's the backbone of the universe. Without it, galaxies would fly apart and cosmic webs wouldn't form. Understanding it could rewrite physics. For instance, if dark matter particles interact weakly with ordinary matter, as theories suggest, detecting them could confirm supersymmetry, a framework tying together all fundamental forces. Or perhaps dark matter is stranger still, composed of primordial black holes or actions, hypothetical particles that might also solve mysteries like the universe's missing antimatter. The practical implications are staggering. Imagine tapping into dark matter's gravitational pull to propel spacecraft, slingshotting them across the solar system without fuel. Or decoding its properties to engineer materials with exotic gravitational behaviors. Even energy could be transformed. If dark matter particles annihilate, as some models predict, they might release pure energy, a potential power source far beyond fossil fuels. Yet challenges remain. Unlike FRBs, dark matter doesn't announce itself with flashes. It's a silent partner requiring painstaking detection. Beyond Euclid, experiments like the LUX Zeppelin detector hunt for dark matter particles deep underground, shielded from cosmic noise. Others, like CERN colliders, attempt to create them in labs. Each approach is a piece of the puzzle, inching us closer to seeing the unseen. As we stand on the brink of these revelations, one thing is clear: dark matter isn't just about filling gaps in our maps. It's about uncovering the universe's hidden rules that might one day let us harness the cosmos itself. And as Euclid begins its survey, we're not just observers. We're detectives decoding the secrets of the dark. Now, let's leap from the invisible to the unhackable. Quantum communication satellites are turning sci-fi into reality, and the implications for Earth are nothing short of revolutionary. Stepping into the realm of cutting-edge security, let's explore how the cosmos is revolutionizing the way we protect our most sensitive data. Quantum communication satellites aren't just a futuristic idea. They're already here, and they're rewriting the rules of cybersecurity. At the forefront of this revolution is China's MISHUS satellite, a trailblazer in quantum encrypted communication. Launched in 2016, MISHUS isn't just a technological marvel. It's a glimpse into a future where hackers and eavesdroppers are rendered powerless, thanks to the bizarre laws of quantum physics. Here's how it works. Traditional encryption relies on complex math problems that, given enough time and computing power, could eventually be cracked, but quantum encryption is different. It uses the principles of quantum mechanics to create unbreakable codes. Specifically, it harnesses a phenomenon called quantum entanglement, where particles become linked across vast distances. Change the state of one particle, and its entangled partner instantly changes too, no matter if they're a millimeter or a million miles apart. MISHUS exploits this by beaming entangled photon pairs from space to ground stations. Any attempt to intercept these photons disrupts their quantum state, alerting both sender and receiver that the communication has been compromised. In other words, hacking becomes impossible without leaving a trace. The implications are staggering. Imagine a world where government secrets, financial transactions, and medical records are shielded by this unhackable technology. No more data breaches, no more stolen identities, no more corporate espionage. Even the most sophisticated cyber attacks would hit a dead end. And it's not just about security. Quantum networks could enable ultra-fast global communication, linking continents with instantaneous, tamper-proof data transfer. But MISHUS is just the beginning. Other nations are racing to launch their own quantum satellites, with the European Union and the United States investing heavily in similar projects. The goal, a quantum internet where every connected device is protected by these unbreakable codes. Picture a future where your smartphone, your smart home, and even your car communicate over a quantum-secured network impervious to cyber threats. Of course, challenges remain. Quantum signals are delicate, easily disrupted by atmospheric interference or even sunlight. Scaling this technology to cover the entire planet will require a constellation of satellites, not just one. Yet, every milestone, like Mishus's successful transmission of a quantum encrypted video call between Beijing and Vienna, brings us closer to that reality. As we stand on the brink of this quantum leap, one thing is clear. The marriage of space technology and quantum physics isn't just about safeguarding data. It's about redefining trust in the digital age, ensuring that our most critical communications remain private, no matter how advanced hackers become. And with each new satellite launched, we're not just securing the future, we're building it. Now, let's turn our attention to another cosmic treasure hunt. Beyond protecting our data, space holds the key to solving Earth's resource shortages, and asteroid mining might just be the answer. Now, imagine turning our gaze to the rocky wanderers of the solar system, asteroids, not just as celestial curiosities, but as cosmic gold mines packed with potential. These ancient remnants from the dawn of our solar system could hold the key to solving some of Earth's most pressing challenges, from dwindling resources to the future of space exploration. Leading the charge is NASA OSIRIS-REx mission, a bold endeavor that's already rewriting the playbook for asteroid mining. In 2020, OSIRIS-REx made history by briefly touching down on the asteroid Bennu, a carbon-rich time capsule orbiting the Sun. Its goal to collect samples and return them to Earth, but this mission isn't just about scientific curiosity. Bennu, like many near-Earth asteroids, is a treasure trove of rare metals, including platinum, gold, and cobalt, materials critical for everything from smartphones to renewable energy technologies. Even more tantalizing is the presence of water ice, which could be split into hydrogen and oxygen to create rocket fuel, effectively turning asteroids into cosmic gas stations for future deep space missions. Here's why this matters. Earth's resources are finite, and mining them often comes with heavy environmental and ethical costs. Asteroids, on the other hand, offer a cleaner, nearly limitless supply. A single metallic asteroid, like the famed Psyche, could contain enough iron and nickel to meet global demand for millions of years, and water-rich asteroids. They could be the pit stops humanity needs to refuel on the way to Mars or beyond, slashing the cost and complexity of long-duration missions. Private companies are already eyeing this opportunity. Firms like Planetary Resources and Deep Space Industries have drafted blueprints for robotic miners that could extract and process asteroid materials in space. Imagine fleets of autonomous spacecraft harvesting water to create orbital fuel depots or ferrying precious metals back to Earth. The economic ripple effect would be monumental, spawning entirely new industries, from space manufacturing to off-world construction. But challenges loom. Asteroids are far away, their surfaces often rugged and unpredictable. Extracting resources in microgravity requires technologies we're still perfecting, like advanced robotics and in situ processing systems. Then there's the legal framework. Who owns what's mined in space? The Outer Space Treaty of 1967 prohibits nations from claiming celestial bodies, but it's silent on commercial exploitation, leaving a gray zone that governments and corporations are racing to clarify. Despite these hurdles, the momentum is undeniable. Japan's Hayabusa missions have proven sample return is possible, and OSIRIS-REx's success has paved the way for even more ambitious endeavors. The European Space Agency's proposed asteroid impact mission aims to test deflection techniques, a critical skill, if we're to safely mine near-Earth objects without accidentally sending them our way. The vision is clear. Asteroid mining could democratize access to rare materials, fuel humanity's expansion into the solar system, and even help preserve Earth's ecosystems by reducing terrestrial mining. It's not science fiction, it's the next chapter in our cosmic story, where the rocks drifting through space become the building blocks of our future. And speaking of cosmic building blocks, let's shift our focus to another celestial mystery, one that stares back at us from the depths of space with an eerie gravitational pull. But before we dive into the mind-bending world of black holes, let's take a moment to appreciate how far we've come in unraveling their secrets. For decades, these cosmic enigmas existed only in equations and artists' renditions, until April 2019, when humanity finally saw the unseeable. The Event Horizon Telescope, a global network of radio observatories spanning from Hawaii to the South Pole, unveiled the first ever image of a black hole at the heart of the galaxy Messier 87. This fuzzy, fiery ring of light wasn't just a scientific triumph. It was a doorway to understanding the most extreme environments in the universe. At the center of that iconic image lies a monster. The supermassive black hole in Messier 87 weighs in at 6.5 billion times the mass of our Sun, warping spacetime so severely that not even light can escape its grasp. The glowing ring we see is actually superheated gas circling the event horizon, the point of no return where gravity becomes unbeatable. But here's what makes this discovery revolutionary. By studying this black hole's shadow against its luminous backdrop, scientists confirmed Einstein's century-old predictions about how gravity bends light, validating general relativity under conditions no lab on Earth could ever replicate. The implications ripple far beyond a single photo. Black holes are cosmic laboratories for testing the laws of physics under extreme conditions. Take time dilation, for example. Near a black hole's event horizon, time slows dramatically compared to the rest of the universe, a phenomenon straight out of sci-fi but grounded in hard science. Understanding this could one day help us navigate the challenges of interstellar travel or even manipulate spacetime itself. Then there's energy. The disks of swirling matter around black holes generate unimaginable power, some of it ejected in jets traveling near light speed. If we could harness even a fraction of that energy, it could revolutionize how civilizations thrive across the cosmos. The Event Horizon Telescope didn't stop at Messier 87. In 2022, it captured our very own Milky Way's central black hole, Sagittarius, a star, revealing a surprisingly quiet beast compared to its more active counterparts. These comparisons help astrophysicists solve puzzles like why some black holes gobble matter voraciously while others seem to starve. There's also the tantalizing possibility of discovering new physics. Some theories suggest black holes might be wormholes to other universes or storage units for hidden dimensions, ideas that could rewrite our understanding of reality. But how do you photograph something that devours light? The answer lies in synchronizing telescopes across the globe to act as one Earth-sized instrument, a technique called very long baseline interferometry. The data collected is so massive it can't be sent over the internet. Hard drives are physically flown to central processing centers. This painstaking effort gives us resolution sharp enough to spot a donut on the moon. Future upgrades aim to include space-based telescopes, sharpening our view further and perhaps even capturing video of black holes in action. What's next? Scientists are already planning to study how black holes evolve over time, how they shape galaxies, and whether their mysteries hold clues to unifying gravity with quantum mechanics, the holy grail of physics. There's even talk of small, artificial black holes being created in particle accelerators to probe their properties up close. Whether as power sources, time machines, or cosmic gateways, black holes are no longer just theoretical oddities. They're real, they're dynamic, and they might just hold the keys to humanity's next great leap forward. And as we peer into these gravitational abysses, another celestial phenomenon tugs at our curiosity, one that doesn't hide in darkness but blazes across the cosmos in fleeting, enigmatic bursts. Shifting our gaze from the depths of black holes to the boundless energy of sunlight, we arrive at a groundbreaking way to conquer the cosmos without burning a single drop of fuel. Imagine spacecraft gliding through space propelled not by fiery rockets, but by the gentle pressure of sunlight itself. This isn't science fiction, it's the reality of solar sails, a technology that could revolutionize how we explore the solar system and beyond. At the forefront of this innovation is the Light Sail 2 mission, a crowd-funded project by the Planetary Society that successfully demonstrated the power of solar sailing in Earth's orbit. Here's how it works. A solar sail is a vast mirror-like sheet made of ultra-thin, reflective material often lighter than a plastic bag. When photons from sunlight hit the sail, they transfer a tiny amount of momentum, giving the spacecraft a gentle push. It's like a breeze filling a boat's sails, except here the wind is made of light. Over time, this constant pressure can accelerate a spacecraft to astonishing speeds without the need for heavy fuel or complex engines. The advantages are game-changing. Traditional rockets rely on carrying massive amounts of fuel, which limits their range and adds enormous cost. Solar sails, on the other hand, require no fuel at all. Once deployed, they can theoretically keep accelerating as long as sunlight reaches them, making long-distance travel more efficient and affordable. Think about missions to Mars or the outer planets. Solar sails could slash travel times and costs, opening up the solar system for more frequent and ambitious exploration. But the potential doesn't stop at our cosmic backyard. For interstellar travel, where distances are measured in light years, solar sails could be our best shot at reaching the stars within a human lifetime. Projects like Breakthrough Starshot aim to harness this technology on an even more ambitious scale. The idea is to use powerful lasers to propel tiny, gram-scale sails to a fraction of light speed, sending them speeding toward Proxima Centauri, the nearest star system to Earth. While still in the conceptual phase, this bold vision highlights how solar sails could transform our reach into the galaxy. Of course, there are challenges. Solar sails need to be enormous to catch enough sunlight, which makes them fragile and tricky to deploy. They're also slower to accelerate compared to conventional rockets, meaning they're better suited for long-haul missions rather than quick trips. But as material science advances, future sails could be made even lighter and more resilient, overcoming these hurdles. What's next for solar sails? Scientists are already dreaming of hybrid systems, combining sails with other propulsion methods for greater flexibility. There's also the exciting prospect of using solar sails to study the sun up close or to position telescopes in unique orbits for groundbreaking astronomy. As we look toward the stars, it's clear that solar sails offer a vision of space travel that's cleaner, faster, and more sustainable. They remind us that sometimes the most powerful forces in the universe are also the most subtle, like sunlight, silently pushing humanity toward the next great frontier. And speaking of cosmic forces, another mysterious signal from deep space has puzzled scientists for decades. Let's unravel the enduring enigma of the WOW signal. Now let's turn our attention from the quiet power of light to something far more audacious, reshaping entire worlds to suit our needs. Terraforming, the idea of transforming a lifeless planet like Mars into a second Earth, might sound like something straight out of a sci-fi novel, but scientists are seriously exploring how we could make it a reality. The dream to create a breathable atmosphere, liquid water, and a stable climate on another planet, giving humanity a backup home among the stars. One of the most talked about targets for terraforming is Mars. Right now, its thin carbon dioxide atmosphere and freezing temperatures make it inhospitable, but researchers have proposed bold ways to change that. One method involves releasing greenhouse gases like methane or even synthetic supergases into the Martian air to trap heat and thicken the atmosphere. Over time, this could raise temperatures enough to melt the planet's ice caps, releasing water vapor and further warming the planet, a cascading effect that might eventually create lakes or even shallow oceans. Another wild idea, smashing icy comets or asteroids into Mars to deliver water and gases in one dramatic move. Or we could deploy orbital mirrors to reflect sunlight onto the poles, speeding up the melting process. These techniques sound extreme, but they're rooted in real planetary science. The challenge is scale. Mars's atmosphere is about 1% as thick as Earth's, so filling it would require an almost unimaginable amount of gas. And even if we succeeded, the process could take centuries, if not millennia. But atmosphere isn't the only hurdle. Mars lacks a strong magnetic field, which means its surface is bombarded by harmful solar radiation. Some scientists suggest building an artificial magnetic shield in space to deflect these rays, while others propose cultivating thick, radiation-resistant plants to slowly enrich the soil. Speaking of plants, genetic engineering could be key. Imagine crops designed to survive Martian conditions, pulling carbon dioxide from the air and producing oxygen as they grow. These superplants might jumpstart a livable environment, but they'd need to thrive in soil laced with toxic perchlorates, a puzzle biologists are still working to solve. The ethics of terraforming are just as complex as the science. Should we alter another planet's ecosystem before thoroughly searching for native life, even if it's just microbes? And who gets to decide how we reshape Mars, governments, corporations, or all of humanity? These questions don't have easy answers, but they remind us that space exploration isn't just about technology, it's about responsibility. Despite the challenges, the vision of a green Mars captivates us because it's more than survival, it's about growth. Turning a barren world into a living one would be humanity's greatest achievement, proving we're not just inhabitants of Earth but stewards of the cosmos. And as we ponder reshaping planets, another mystery from the depths of space demands our attention. Decades ago, a radio signal from the stars stunned astronomers, only to vanish without a trace. Let's revisit the enigma of the WOW signal. Now let's shift from shaping planets to deciphering one of space's most tantalizing mysteries, a signal that still echoes through the decades with unanswered questions. On a quiet August night in 1977, an Ohio radio telescope picked up something extraordinary. For 72 seconds, a burst of radio waves blared from the constellation Sagittarius, so intense that astronomer Jerry Amon circled the data printout in red pen and scribbled "WOW" next to it, giving the signal its legendary name. What made this signal so special? For starters, it matched the exact frequency scientists predicted an extraterrestrial broadcast would use: 1420 MHz, a quiet band where earthly interference is minimal. It also had the hallmarks of an artificial transmission, narrow and powerful, unlike the scattered noise of cosmic phenomena. But just as suddenly as it appeared, it vanished, never detected again despite decades of searching. Was it a fleeting hello from another civilization, or something else entirely? Modern astronomers have revisited the WOW signal with sharper tools and fresh theories. Some suggest it could have been a comet's hydrogen cloud glowing at that specific frequency, except no known comets were in that part of the sky at the time. Others propose it might have been a rogue signal bounced off space debris, though none match the profile. And then there's the unsettling possibility that it was alien in origin, a brief blip from a distant transmitter we simply weren't listening to long enough to catch again. The mystery deepens when you consider the implications. If it was extraterrestrial, why hasn't it repeated? Civilizations advanced enough to send signals might not broadcast continuously. Perhaps they pulse messages sporadically, or we missed their follow-ups. Alternatively, maybe they're deliberately avoiding detection, a concept some call the dark forest hypothesis, where advanced societies stay silent to avoid attracting threats. The WOW signal also forces us to confront how little we truly know about the cosmos. Even with today's arrays of radio telescopes and projects like SETI, space is vast and signals are easy to miss. It's like trying to hear a whisper in a hurricane. Yet this one flicker of data reminds us that the universe might not be as empty as it seems, and that the next signal could come any day, rewriting humanity's place in the cosmic story. As we ponder the silence between the stars, another frontier of discovery pulls our gaze ripples in the very fabric of spacetime itself. Let's explore how gravitational waves are unveiling collisions older than Earth itself. From whispers in the cosmos to the thunderous crashes of celestial giants, let's dive into one of the most profound discoveries in modern astronomy: gravitational waves. These invisible ripples in the fabric of spacetime, first predicted by Einstein over a century ago, were finally detected in 2015 by the Laser Interferometer Gravitational Wave Observatory, or LIGO. What started as a theoretical curiosity has since opened a whole new window into the universe, allowing us to hear the violent mergers of black holes and neutron stars billions of light years away. So how does LIGO catch these elusive waves? Imagine spacetime as a still pond. When massive objects like black holes spiral toward each other, they send out ripples stretching and squeezing space itself as they travel outward at the speed of light. LIGO detectors, with their L-shaped tunnels stretching 4 kilometers long, use lasers to measure these tiny distortions, changes smaller than 1/10,000th the width of a proton. The first detected wave, named GW150914, came from 2 black holes 30 times the mass of our Sun colliding 1.3 billion years ago. The event released more energy in gravitational waves than all the stars in the observable universe combined, yet by the time those ripples reached Earth, they moved LIGO mirrors by less than the width of an atom. Beyond confirming Einstein's theory, these discoveries have reshaped our understanding of the cosmos. Before LIGO, black holes were mostly inferred from their effects on nearby matter. Now we've heard them merge over 50 times, revealing populations of black holes larger than any seen through telescopes. Neutron star collisions, like GW170817, have also given us front-row seats to cosmic gold factories, literally. These crashes forge heavy elements like gold and platinum, solving the mystery of where such rare metals originate. But perhaps the most tantalizing possibility lies in what gravitational waves could reveal next. Some theories suggest they might carry hints of extra dimensions or deviations from Einstein's equations in extreme gravity environments, clues that could lead to a unified theory of physics. Others propose using waves to study the universe's earliest moments, probing epochs before light could travel freely. With next-generation detectors like LISA, a space-based observatory planned for the 2030s, we might even catch waves from the supermassive black holes at galactic centers or primordial ripples from the Big Bang itself. What makes this detection method so revolutionary is its independence from light. Unlike telescopes limited by dust or distance, gravitational waves pass through everything, offering an unobstructed view of the darkest, most energetic events. It's like adding sound to a silent movie suddenly. The universe isn't just something we see, but something we can hear. And as our ears grow sharper, who knows what other cosmic symphonies await. Speaking of unseen forces shaping the cosmos, let's turn our attention to an icy moon where another ocean, not of waves but of liquid water, might hold secrets about life's potential beyond Earth. Now let's journey from the echoing ripples of spacetime to a world shrouded in ice, where an ocean hidden beneath its frozen shell could rewrite the story of life itself. Europa, Jupiter's enigmatic moon, has long captivated scientists with its cracked, icy surface and the tantalizing possibility of a vast subsurface ocean. NASA's upcoming Clipper mission aims to peel back those icy layers, probing for conditions that might nurture life beyond Earth. What makes Europa so special? Picture this: beneath a crust of ice up to 25 kilometers thick sloshes a global ocean, kept liquid by the immense tidal forces of Jupiter's gravity. This isn't just any ocean, it's thought to contain twice the volume of all Earth's seas combined, with salt water potentially rich in chemistry that could fuel life. Hydrothermal vents on Europa's seafloor, much like those in Earth's deepest oceans, might provide the energy and nutrients needed for microbial organisms to thrive. The Clipper mission, set to launch in the coming years, is our best shot at uncovering these secrets. Unlike previous flybys, Clipper will orbit Jupiter and make dozens of close passes over Europa, mapping its surface, measuring the thickness of its ice shell, and even sniffing out plumes of water vapor that occasionally erupt into space. Its suite of instruments includes ice-penetrating radar to peer beneath the surface, thermal imagers to spot warmer regions where liquid might rise, and spectrometers to analyze the composition of those plumes. If organic molecules or signs of metabolic activity are detected, it could be the strongest hint yet that we're not alone in the cosmos, but the real game changer. The potential for future missions to drill through Europa's ice. Engineers are already conceptualizing cryobots melting probes that could tunnel down to the ocean, deploying submersibles to explore this alien abyss. Imagine discovering ecosystems akin to Earth's hydrothermal vent communities, where life flourishes in utter darkness. Such a find wouldn't just expand our understanding of biology, it would prove that life can spark and survive in the most unexpected corners of the universe. Beyond the search for life, Europa's ocean holds clues about the Moon's geologic activity. Its fractured, chaotic terrain suggests the ice shell shifts and renews itself, possibly creating habitats where water and rock interact. Some scientists even speculate about shallow pockets of liquid water closer to the surface, accessible to future landers. Each layer we peel back could reveal new surprises, from exotic ice formations to processes that recycle nutrients like a cosmic conveyor belt. The implications are staggering. If life exists on Europa, it would mean the solar system harbors at least two worlds where biology has taken hold. That would vastly increase the odds of finding life elsewhere, from the subsurface oceans of Saturn's Enceladus to exoplanets with similar conditions. Europa's story isn't just about one moon, it's about redefining what's possible in our search for living worlds. As we prepare to unlock Europa's frozen vault, we stand on the brink of answering one of humanity's oldest questions: are we alone? The Clipper mission is the first step, but the discoveries it enables could echo through centuries of science. And speaking of cosmic energy, let's shift our gaze to an ambitious idea that could power our future, harnessing sunlight not on Earth, but in the endless expanse of space itself. Now, let's turn our attention from the icy depths of Europa to a dazzling idea that could revolutionize how we power our planet, harnessing the sun's energy not just on Earth, but from space itself. Imagine a future where massive solar arrays orbit high above us, soaking up sunlight 24 hours a day, uninterrupted by clouds or nighttime, then beaming that energy back to Earth as clean, limitless electricity. This isn't science fiction, it's the cutting edge of space-based solar power, and it could be the key to ending our reliance on fossil fuels. The concept is simple yet brilliant. In space, sunlight is up to 10 times more intense than on Earth's surface, with no atmosphere to scatter or absorb its rays. Solar panels in orbit could generate power around the clock, unlike ground-based systems that depend on daylight and weather. The real challenge: getting that energy back to us. Engineers are testing two main methods: converting solar energy into microwaves or lasers, which can then be transmitted wirelessly to receiving stations on Earth. These rectifying antennas would convert the beams back into electricity, feeding it directly into our power grids. One of the most promising projects is led by the Japan Aerospace Exploration Agency, which successfully transmitted solar power via microwaves over short distances in lab tests. They aim to launch a full-scale orbital demonstrator by the 2030s. Meanwhile, the U.S. Naval Research Lab has tested a modular solar satellite design, and private companies like Saturn have secured contracts to supply space-based power to utilities. Even China has announced plans for a megawatt-level space solar station by 2035 with a gigawatt-scale system enough to power a large city by mid-century. The benefits are staggering. Space-based solar could provide a constant global energy supply, eliminating the intermittency issues of wind and ground-based solar. It would reduce greenhouse gas emissions dramatically, slashing our dependence on coal and oil. Remote areas, disaster zones, or even future moon bases could gain instant access to power without expensive infrastructure. And unlike nuclear, there's no radioactive waste, just sunlight converted and shared. But the hurdles are equally daunting. Launching massive solar arrays into orbit is currently prohibitively expensive, though reusable rockets like SpaceX's Starship could change that. Engineers must also perfect the efficiency of wireless power transmission and ensure the beams are perfectly targeted to avoid safety risks. Critics worry about the potential for weaponization or accidental interference with aircraft and satellites. Yet, with climate change accelerating, the urgency to find scalable clean energy solutions has never been greater. What makes this truly exciting is how close we are to making it real. The European Space Agency recently funded a study on commercializing space solar power, while the UK government has invested in developing the underlying technology. Even NASA, which shelved the idea in the 1970s due to technical limits, is revisiting it with modern innovations. Smaller-scale prototypes could be in orbit within the next decade, paving the way for larger systems. Picture this, a network of solar satellites, each the size of a small town, silently powering entire nations without a single smokestack. It's a vision of the future where energy scarcity becomes a relic of the past, and where humanity's leap into space tangibly improves life on Earth. As we push the boundaries of what's possible, space-based solar power isn't just about clean energy, it's about reimagining our relationship with the cosmos itself. And this brings us to another cosmic mystery, one that's been pulling galaxies, including our own, toward it with irresistible force. Let's unravel the enigma of the Great Attractor. Now, let's journey deeper into the cosmos to confront one of the most perplexing mysteries in modern astronomy, the Great Attractor. Picture this, our Milky Way, along with thousands of other galaxies, is racing through space at an astonishing speed of over 2 million kilometers per hour. But here's the catch, we don't fully know what's pulling us. This invisible, colossal force has puzzled scientists for decades, and unraveling its secrets could rewrite our understanding of the universe's very fabric. The story begins in the 1970s when astronomers first noticed something odd. Galaxies in our cosmic neighborhood, including our own, weren't moving randomly. Instead, they were all being drawn toward a specific region of space roughly 250 million light-years away, near the constellation Centaurus. They called this mysterious focal point the Great Attractor, but here's the twist: when scientists pointed their telescopes in that direction, they found nothing obvious, no supercluster of galaxies, no gargantuan black hole, nothing dense enough to explain the gravitational pull. It was as if the universe was hiding a cosmic magician behind the curtain. So what's really going on? The leading theory suggests the Great Attractor isn't a single object but a massive concentration of dark matter, the invisible scaffold that makes up about 85% of the universe's mass. Dark matter doesn't emit light, but its gravity bends space, tugging galaxies like ours toward it. Compounding the mystery, our view of this region is obscured by the dusty plain of the Milky Way, a cosmic blind spot nicknamed the Zone of Avoidance. It's like trying to study a mountain while standing in a fog bank. Recent breakthroughs, however, are peeling back the veil. Using infrared and radio telescopes that peer through the dust, astronomers have mapped hidden galaxies in the Great Attractor's vicinity, revealing a sprawling supercluster called Laniakea Hawaiian for immeasurable heaven. This cosmic web, spanning 500 million light-years, may be the true source of the pull, with the Great Attractor as its densest node. but even Laniakea might not be the full story. Some researchers propose an even larger structure beyond it, like the Shapley supercluster, could be adding to the gravitational tug of war. Why does this matter? Solving the Great Attractor mystery could reshape cosmology itself. If dark matter is the culprit, it would confirm our models of how the universe's unseen infrastructure shapes galaxy motion. If something else like exotic physics or undiscovered mass is at play, it could upend those models entirely. Either way, understanding this force would shed light on the ultimate fate of our galaxy and the large-scale structure of the cosmos. The quest continues. Upcoming missions like the European Space Agency's Euclid telescope, launching this decade, will map dark matter in unprecedented detail, potentially pinpointing the attractor's true nature. Meanwhile, radio surveys are piercing the zone of avoidance, uncovering more hidden galaxies. With every new discovery, we inch closer to solving one of space's greatest riddles. And as we ponder the forces tugging at our galaxy, another question arises. Could the building blocks of life itself have originated beyond Earth? That brings us to our next discovery: evidence for panspermia, the idea that life's ingredients are scattered across the cosmos. Now, let's turn our gaze from the mysteries of dark matter to an even more profound question. Could life on Earth have come from the stars? The idea isn't as far-fetched as it might sound. Scientists call it panspermia, the theory that life's essential ingredients, or even life itself, might have hitchhiked across the cosmos to reach our planet. And the evidence, it's piling up in ways that could rewrite the story of our origins. Take amino acids, for instance. These tiny molecules are the Lego blocks of proteins, essential for life as we know it. For decades, researchers assumed they could only form on Earth under just the right conditions. But then came the surprises. In 1969, a meteorite named Murchison crashed in Australia, and inside it, scientists found over 90 different amino acids, many of which are never seen on Earth. This wasn't a fluke. Similar organic compounds have been detected in the tails of comets, like Comet Wild 2, and even in the icy plumes of Saturn's moon Enceladus. Space, it turns out, might be teeming with life's raw materials. But how could these fragile molecules survive the harshness of space? Experiments on the International Space Station have shown some amino acids can endure extreme radiation and vacuum conditions when sheltered inside asteroids or comets. Imagine a cosmic delivery system, asteroids acting as interstellar freight trains, carrying organic cargo across the galaxy. Some researchers go further, suggesting that entire microbes, like ultra-hardy bacteria or tardigrades, might survive such journeys shielded inside rocks. In fact, tests have shown certain bacteria can withstand the vacuum of space for years, lending credence to this wild idea. The implications are staggering. If life's building blocks are common in space, then planets like Earth might not be rare oases but part of a vast, interconnected network of life-friendly worlds. Consider this: the same amino acids found in meteorites match those used by life on Earth. Could our DNA have extraterrestrial roots? Some scientists speculate that early Earth, bombarded by comets and asteroids during the late heavy bombardment 4 billion years ago, might have been seeded with these probiotic molecules, jump-starting life in our planet's primordial soup. Yet panspermia isn't just about the past, it's a roadmap for the future. Missions like NASA OSIRIS-REx and Japan's Hayabusa 2 are bringing back asteroid samples, hunting for more clues. Meanwhile, the James Webb Space Telescope is analyzing the atmospheres of distant exoplanets, searching for organic fingerprints. If we find life or its precursors on another world, it might share a cosmic ancestry with us. Of course, skeptics argue that panspermia merely shifts the mystery of life's origins elsewhere. But whether life began on Earth or arrived here, one thing is clear: the universe seems prepped for life, and we might be part of something far grander than we ever imagined. And speaking of grand cosmic puzzles, our next discovery takes us to the cutting edge of space technology, breakthroughs in artificial gravity that could make long-term space habitation a reality. Now, let's tackle one of the biggest hurdles to living among the stars: gravity, or rather, the lack of it. Floating might look fun in movies, but the reality is far harsher. Without gravity, astronauts face muscle atrophy, bone loss, and even vision problems over time. But what if we could trick the human body into feeling at home, even in the void of space? That's where artificial gravity breakthroughs come in, and the science behind it is as clever as it is crucial. The most straightforward solution: spin your spacecraft. Picture this, a rotating habitat where the centrifugal force pushes objects and people outward against the walls, mimicking gravity's pull. It's not science fiction. NASA and private companies like SpaceX have seriously studied spinning designs, from compact centrifuges inside stations to giant rotating rings reminiscent of classic sci-fi. The International Space Station even tested a small centrifuge for mice, proving the concept works. But scaling up for humans isn't easy, too slow, and the effect is weak. Too fast, and astronauts get dizzy from the Coriolis effect, where fluid in their inner ears spins unpredictably. Finding that sweet spot is key, and experiments suggest rotations between 10 and 30 revolutions per minute could work, depending on the habitat size. Then there's the magnetic approach. Scientists are exploring whether powerful magnetic fields could simulate gravity's effects on the human body, at least partially. While this tech is still in early stages, studies show magnetism can influence cellular behavior, potentially counteracting some zero-gravity harms. Imagine floating in a cabin where an invisible force gently anchors you, no spinning required. It sounds futuristic, but labs on Earth are already testing magnetic boots and suits that could one day make this a reality. But why stop at prevention? Artificial gravity could revolutionize space travel itself. Long voyages to Mars or beyond won't just risk health decline, they'll demand peak physical performance. A spinning ship could let astronauts exercise naturally, maintain bone density, and even sleep better. Private ventures like Gateway Foundation's rotating space hotels are banking on this, aiming to make off-world living not just survivable but comfortable. The stakes couldn't be higher. Without solving gravity, human expansion into space hits a biological wall. But with these innovations, we're not just dreaming of colonies on Mars, we're engineering the tools to thrive there. And as we push these boundaries, we're forced to ask, is artificial gravity the missing puzzle piece for our interstellar future? Speaking of puzzles, our next discovery plunges us into one of cosmology's greatest enigmas, the Fermi paradox, and why the universe seems so silent despite its potential for life. Now, let's shift our gaze to one of the most unsettling questions in cosmology. Why does the universe, with its countless stars and planets, seem so eerily quiet? This is the heart of the Fermi paradox, a puzzle that has baffled scientists for decades. If the conditions for life are so abundant, why haven't we found any signs of it beyond Earth? One explanation gaining traction is the dark forest hypothesis, a chilling theory inspired by the idea that the cosmos might be like a vast, silent forest. In this scenario, every civilization hides, fearing that revealing itself could invite destruction. Think of it as a cosmic game of hide and seek, where making noise, like sending out radio signals, could attract hostile advanced societies. It's a sobering thought. Could the reason we haven't heard from aliens be because staying silent is the only way to survive? But not all answers are so grim. Another possibility is that we're simply too early to the party. The universe is nearly 14 billion years old, but complex life might be a recent phenomenon. Civilizations could be rare, separated by vast stretches of time as well as space. Or perhaps advanced societies evolve beyond the need for physical expansion, turning inward to virtual realities or other dimensions we can't yet detect. Then there's the Great Filter theory, which suggests that somewhere along the path from simple chemistry to interstellar civilization, there's a nearly insurmountable barrier. If the filter is behind us, like the improbable leap to multicellular life, we might be alone. But if it's ahead of us, say, self-destruction through war or climate collapse, that's a far more troubling prospect for humanity's future. Recent data adds new twists to the debate. The James Webb Space Telescope has revealed countless Earth-like worlds, yet none show signs of megastructures or industrial activity. Meanwhile, projects like SETI have scanned the skies for decades without a single confirmed alien signal. Some scientists argue we're not looking for the right things, like neutrino messages or quantum communication, while others suggest we might be missing subtle signs hidden in plain sight. The stakes couldn't be higher. If the dark forest is real, broadcasting our location could be dangerous. But if civilizations tend to self-destruct, our survival may depend on learning from their silence. Either way, the Fermi paradox forces us to confront our place in the cosmos. Are we destined to be alone, or is someone out there waiting for the right moment to reveal themselves? Up next, we'll dive into the James Webb Space Telescope's most jaw-dropping discoveries and how they're reshaping our understanding of the universe's earliest moments. Now, let's turn our attention to a game-changer in modern astronomy, the James Webb Space Telescope. Since its launch, this extraordinary instrument has been peeling back the layers of the cosmos, revealing secrets that were once beyond our reach. Its findings aren't just groundbreaking, they're rewriting the very textbooks astronomers rely on. One of Webb's most stunning discoveries is the detection of galaxies so ancient they shouldn't exist. These cosmic relics, spotted just a few 100 million years after the Big Bang, are far larger and more mature than our models predicted. It's like finding a fully formed city in what we thought was an empty wilderness. This challenges our understanding of how quickly stars and galaxies assembled in the early universe, forcing scientists to rethink the timeline of cosmic evolution. Then there's Webb's work on exoplanets, worlds orbiting distant stars. For the first time, we've been able to study the atmospheres of Earth-sized planets in detail. Take the rocky planet TRAPPIST-1e, for example. Webb detected water vapor and carbon dioxide in its atmosphere, clues that it might have the right conditions for liquid water. While we haven't found definitive signs of life yet, these discoveries bring us closer than ever to answering the ultimate question: are we alone? But Webb's surprises don't stop there. It's also spotted bizarre chemical signatures in the atmospheres of gas giants, like sulfur dioxide on a scorching world called WASP-39b. These molecules act as cosmic fingerprints, revealing how planets form and migrate around their stars. And in our own solar system, Webb has uncovered unexpected details about Jupiter's storms and the faint rings of Uranus, proving even familiar places still hold mysteries. Perhaps most mind-bending of all is Webb's ability to see through cosmic dust. In the iconic Pillars of Creation, it exposed newborn stars hidden within the nebula's dense clouds, offering a front-row seat to stellar birth. This kind of clarity wasn't possible with earlier telescopes, and it's opening new windows into how stars and planetary systems emerge from the chaos of space. The implications are staggering. Webb's data isn't just filling gaps in our knowledge, it's revealing an entirely new cosmic story. From ancient galaxies that defy expectations to exoplanets with the ingredients for life, every discovery sparks fresh questions and missions. Future telescopes, like the upcoming Habitable Worlds Observatory, will build on Webb's legacy, pushing us closer to finding life beyond Earth or even uncovering new physics. As we wrap up our journey through these 20 transformative discoveries, remember each revelation is a stepping stone. Whether it's water on Mars, the enigma of dark matter, or Webb's stunning snapshots of the infant universe, they all point to one truth: space isn't just about distant stars and planets. It's about our future, These breakthroughs could redefine energy, communication, and even our survival as a species. So stay curious, because the next cosmic game changer might be just over the horizon. If you've enjoyed this cosmic deep dive, don't forget to hit like, subscribe, and ring that notification bell for more mind-expanding space content. The universe is full of wonders, and we're just getting started. Now, let's take a moment to reflect on the incredible journey we've just taken through the cosmos. From the waters hiding beneath Mars' rust-colored surface to the mind-bending mysteries of dark matter, these 20 discoveries aren't just scientific milestones, they're blueprints for humanity's future. Imagine a world where we harness asteroid minerals to build cities in space, or where quantum satellites protect our global communications from hackers. Picture colonies thriving on Mars, fueled by ice mined from its poles, or telescopes like the James Webb revealing alien forests on distant exoplanets. Every breakthrough we've explored, whether it's the organic molecules on Enceladus or the eerie silence behind the Fermi paradox, holds the potential to redefine life as we know it. Think about how these discoveries intertwine. Water on Mars could sustain astronauts, while Europa's hidden ocean might teach us how life begins. Dark matter maps might lead to new energy sources, and solar sails could carry probes to Proxima Centauri within our lifetime. Even the great attractor's pull, a cosmic mystery we're still unraveling, could rewrite the rules of gravity. Together, they paint a future where Earth isn't humanity's only home, but the first of many. Yet the most thrilling part, this is just the beginning. Every unanswered question, like the true nature of Oumuamua or the source of fast radio bursts, is an invitation. An invitation to explore, to innovate, and perhaps one day to shake hands with another intelligent species. The cosmos isn't a static backdrop, it's an active participant in our story, offering clues and challenges in equal measure. So, what's your role in this grand adventure? Stay curious, share these wonders with others, debate whether we should terraform Mars or protect its pristine deserts. Wonder if the wow signal was a cosmic hello or just a stellar hiccup. The more we question, the closer we get to truths that could unite our planet under a common interstellar destiny. If this journey through space's greatest mysteries has sparked your imagination, don't let it end here. Hit that subscribe button and ring the notification bell, because the universe has endless surprises left to share. From black hole breakthroughs to the search for extraterrestrial life, we'll keep bringing you the stories that shape our cosmic future. Thanks for exploring with us. Now go outside, look up, and remember, the next era of space discovery might start